All right, we're live there.
Sorry, Kristen.
I'm trying to trap you.
Oh.
Right. Yeah. No, that's it's like a real.
All right, let's take another minute if you haven't added some comments to this. And I will, let's see what we've got here. New problem, new data set. Determining your time series plot. Mins and maxes. Yeah, it's pretty fun once you start to figure out how to filter and summarize. You know, there's a lot of really cool things you can do. What is time really? I ask myself that every day. Using POSIX functions with our tidyverse functions is a little confusing. Okay. What is love? All right. So, where do I even begin? No, this is great. So, overall, I totally, I know we're going to sort of, the last few weeks have been somewhat, I would say, more longer, sort of long form assignments. Good news, we're not really going to have one of those this week. We want you all to breathe and we're just going to, we'll have a few fairly straightforward things that are not really like an assignment you can go through. But I think it is really good to force yourself to work with other data, right, and actually practice doing this. So it's kind of fun. Having said that, you know, it can be definitely, and time in particular is a tricky type of data in R because there can be sort of multiple forms, right? There's the POSIX continuous time, there's a POSIX LT, which is sort of a different structure, and then there's the date, regular dates. So that is completely understandable. We're going to work a little bit more with times today to get a handle on that. The other thing is I want to show you some more functions because we kind of whipped through it last week and then sort of left you to the wolves for the assignment. So I do want to walk through like a few of the main things that I find that I do a lot. Getting ggplot to work with multiple variables is really common, and it takes a lot of practice to think about how to structure your data. So remember, ggplot likes things in a long form, not in a wide form, right? So if you're adding additional variables, it needs to be on the same sort of axes that your data exists in, but it also needs to be structured in a way that either you might need to call an entirely new data set, right? If you have different data sets or different variables, or think about faceting or using color or shape to display additional variables. But it's not really transparent initially when you're starting to do this. But it's kind of exciting because there are so many different ways to display your data. I don't even know where to go with that, but I agree. My graphs are bad and I feel bad. Don't feel bad. If I showed you the things that I made when I was first learning R, you would probably not want me up here talking to you about how to do stuff in R. So I honestly think that classes like this and the time that you're getting spent here, you are leaps and bounds ahead of other people who are trying to learn this on their own, okay? So having said that, it's a trial and error. It's going to take time until you kind of get dialed into like what works for you, but that's part of why we're here. So don't feel bad about your code. Don't feel bad about your figures. We're all here learning, myself included. There's oftentimes people have stuff and I'm like, I have no idea what that is. And I've been doing this, I've been making more mistakes than you have for longer. So it still happens. Yeah.
I guess to follow on from that, when the class is over,
yeah,
you still post things on our class forum.
Of course, yeah, yes.
Okay.
So there's no, it's not like we're going to delete the Ents group and the GitHub. All your repos get wiped. They will all be there, okay? So I highly encourage you, like use that. It's a great resource. You are all great resources for each other. You have this great discussion board. You have these tools now. We would love to see that sort of continue. Even if it's like 6 months later, just out of the blue, you get like a message like, hey, guess what? I forgot I was part of this, but use it. That's what it's there for. You're there for each other. We have groups like the Davis R users group on campus that you're more than welcome to come and post. But I also recognize that, sending an email that goes to 800 people is a little more intimidating than sending it to like our class, right? Or to Mike or I. So anybody that's part of this, please use us. Like, take advantage, ask a question. We'll do our best. And then the last one is timestamp. Oh, I'll talk about that in a minute. Any other questions specifically like about the assignment, burning questions that you feel like we didn't really talk about or that you don't understand? No. Okay, sweet. So let's go ahead and jump over. So the plan for today, we're going to be working in this R Markdown live code, which is on the website. Let's go to the website here, and hopefully it's refreshed by now. So under lectures, week 9, which is crazy, live code. So if you click on that, it should jump over to the R Markdown here, okay? And then the screencast is here and the Google Doc is there. So today I'm going to go through a bit of under times and dates with LibreDate here. I'm going to go over some of the stuff down towards the bottom, this sort of secondary example with this logger data that we used. So first off, let's open our studio. Oh, I need to make this a different color so you can probably see it better. Sorry. Appearance, let's make this Xcode. Okay, there we go. And then let's make it a little bigger. How's that in the back? Can you see that? All right, sweet. Okay, so to start, I just want to talk a little more about LibreDate and a few functions that we sort of talked about but really rushed through. You may have seen them in the homework assignments. So first, let's go ahead and load our libraries. We're going to load LibreDate and Tidyverse. Okay. And then the next thing I want us to do is over on the website, I've grabbed 2 different logger data sets. And I'm going to tell you a little bit about them. Let's go look at them. So over in resources and data sets, down at the bottom here, there's 3, it's like really at the bottom. See if I can make that go up a little bit. Hang on. There we go. Okay, there's 3 data sets that all start with the word Solence, which is just the type of logger. So these are, for those of you that do stuff with water, these are like little silver loggers that measure pressure and temperature. And so you can actually measure the level of the water. We use them all over the place in rivers and stuff. They're great. But what I have here is this one is the full data set. So it's a lot of rows. I think it's 35,000 rows. Basically 15-minute data in a river for a year. Okay. What I did is split these into 2 different files, A and B. And what I'm going to show you and what Mike is going to talk about is joining data, right? So say you get, this is really common, you get multiple data pieces and they're kind of in different pieces and you want to join them all together. Well, there's 2 options, right? We can either just stack them, bind them together, and we may have talked about bind, cbind or rbind or bind rows. You may have seen or heard that. That's basically just appending whatever part A to part B, okay? The problem is, what if you have overlap? And I've specifically made these overlap by 1 month. So you actually have duplicated data in each one. You have 1 month of data in one month in the other. So then what do? Well, you could manually go in and figure out where it is and trim it out in Excel, but that really doesn't sound very fun, nor is it really repeatable. So that's where joins become a really amazing tool, right? Because joins, you can join the same way we group by, right, in dplyr. You can join on different columns, and those columns can recognize if you have a set date or a date time. If there's the same date time across those rows, it'll only keep 1, right? And so you can merge things together and only take the distinct ones. You can actually use something called an anti-join, which is just awesome, but that actually finds records that are different, that are sort of different between the 2. There's a whole bunch of things that you can do. Mike's going to talk a little bit more about those, okay? But I'm going to show a really quick example using these 2 data sets. So keep these in mind. What we're going to do is we're going to read them in straight from this web URL. But if you want to download them to your data folder, you can do that as well. So I'm going to copy this link for Solence A. I'm going to right-click and copy link address. And I'm going to go over to RStudio. And I'm going to make a new chunk. Let's say, let's read in our logger data. So let's get part A and part B into our environment. Okay. Then we're going to make a chunk here. I think for me it's Command Option I, but you could do Control Option or Control Alt I, something like that. I'm going to name this chunk load logger data. Now I'm going to, so we have tidyverse loaded and we have lubridate loaded. So that means I can use, let's call this logger A. I'm going to use read CSV. Now, here's the interesting bit. So you can add a, under file, URL. And if I go ahead and run this, let's see what happens. So here's the fun part about data. We didn't look at it before we tried to load it up, right? And look what it said. It says serial number, some other blank columns, missing column names. Generally, it doesn't look like good things happened. There's a lot of warning text there. It says there's 17,000 observations with 5 variables. And none of these look like they worked. So this doesn't look quite right. The reason is I happen to have this already in my data folder. And so I'm going to show you, I do not happen to have this in my data folder. Perfect. Well, let's go ahead and, so what if I click on this? It'll download it. All right, so let's download it to our data folder and take a look at it real quick. Where is that? This live code. I'm putting it in data. Save. Great. All right, so let's look at this. I'm just opening it up in Excel or some spreadsheet program if you have one. Where is it? Oh, it's on a wrong screen. Hang on. Okay. Aha. Well, that's different. So look at this. It has a header. And the way this works is this is common in a lot of files. You get logger files, climate data, precip. A lot of things will, they have sort of station data or location data or whatever it is at the beginning of your file, right? Problem is you don't want any of that. You don't need any of that at the moment. You want to start reading the data, which starts on row 14, okay? So not a problem. I just needed to look and see where that is because I'm going to basically say skip these first rows and start at 14. I just want data starting below that. So let's go back to our code. And inside of this function, read CSV, if I hit tab, there should be an option down here called skip, right? Skip equals, and what was it? I want to skip 13 rows, right? Because I wanted to include the header of what the different data, what the columns are. Okay, great. Making progress. So I'm going to send that, go ahead and run that. And bring this down. Aha, that looks much nicer, right? So now it actually has some column names. It tells me what they have, what they are. And it's actually already trying to recognize this as time. Integer, double, which is so numeric, and date, it formatted the date as a character. Great. All right. So let's do the same thing for the B. And it's the same kind of file with the same 13-line header. So I'm changing these just to B. It's named the same, just changing the B. Okay. So now in my environment, let's take a look here. Oh, yes.
The file is A for B. A twice.
It's A twice.
Yeah, well, when you're on the website.
Shoot. Sorry. Let's check that out. This is what happens when you do things late at night. Yeah, that's both the same file. Sweet. Okay. All right, that's all right. We'll do A and this one. So it's basically, yeah, Mike.
I can put E on the like it's in the data.
It's perfect. Thank you.
It seems like it actually worked for you to just change.
It worked.
Actually pulled in a different data set. You changed the HTTP address. It's
I think the link exists. It's just that that's wrong. Is that correct?
That's correct.
Okay.
You'll change that link, but if you just change AT, then it should
Still work.
get a different data.
Okay. So ignore the website and do what I did in the code. So I just saved this, so you can copy this over if you want. So I have B and B. It must have worked because look at I have a different number for each one, right? I have 17,236 and 20,778. And the way this looks is they're the same exact data. If I open this up, I have date, time, this column called MS, which is milliseconds. It's the chart, like how much battery exists in the logger. Level, which is the stage or in meters of the water, and the water temperature in Celsius, okay? So same columns, same names, everything's the same. The only difference is there's different, notice this one starts on January 1st, 2015. This one starts on August 5th, 2014, okay? So one way, now that we have this, let's take a quick look to summary of logger A and see if we can see when the date starts and stops. Oh, we can't because it's a character. Actually, let's pause. So green stickies, if you have them, make sure everybody has this read into your R. Or if you don't have a green sticky and you haven't, just raise your hand. Okay. Cool. Sorry, I should pause more often. So did everybody see what I did? I ran summary because I wanted to see what the data looks like. And it looks like I have this nice numeric range of data for my level and temperature. But it's not telling me anything for date and time, at least nothing useful, because it hasn't been formatted yet. It's still in this sort of character format. So this is where LubriDate comes in. And we are going to format this as date time because we have both columns. They're separated. And so to do that, let's make a date time column. I'm going to make a new chunk. Make a date time column. And using paste or paste 0. I'm going to talk about these. Did anybody use these in the homework? Yeah? Ish? Okay. Does anybody have an idea what the difference between paste and paste 0 is?
0 assumes comma separation.
Right. Yeah. So paste, you can separate by whatever you want. You could separate by a slash. Like if you had data that was separated by lots of slashes or weird characters, you can enter those. The default is typically a comma. And so paste 0 saves you sort of an extra, some typing. Because paste 0 assumes separator between fields you are pasting together is a comma. Okay. Paste is more flexible, and you have to specify a column limiter. Does that make sense to folks? Ish. Let's see it in action. All right, so let's make a new chunk. Make date time. Move that up a bit. Okay, so we have these two data sets. We have date and time columns, and we want to make a date time column that we format with LubriDate. So if we're using dplyr, how do we add a new column? Mutate, awesome. So let's try that. So let's say logger A. I'm assigning this so that it writes this new column to the same set we have, data frame we have. Logger A, I'm piping that to mutate. And now what do I want to say? Let's call it date time. And if we're going to use paste 0, see it pops up here. Notice the paste, it has this, it says concatenate vectors after converting to character. So it converts everything to character and squishes whatever you want together. Separated by a space in this case. But if we want to use paste 0, notice it drops that separator because the default is separating by a comma. So let's use paste 0, and we're going to use date, comma, time. Okay, any questions on that? So let's just run this bit, and then let's try a glimpse of our data. There we go. Now we have a date time column. Huh, what happened there? We squished it together, right? We just basically pushed them right next to each other, which is okay, but ideally we probably want it to look like an actual date time, right? So how can we change this call to work more appropriately?
0 would want to say add a space either after date or time.
How do I do that?
In quotes.
In quotes. Right, quote, space, comma. Okay, so now if I run this in glimpse, now we've got a date time that looks like a date and a time, right? So we've added a space in there. Yeah.
How come we didn't have to do like defining what the year and month and day is? How come it just?
We're gonna do that next. So we don't right now. This is still a character. See, it's still a character type of date.
Yeah.
For class of data, and this is considered a time. It recognizes it as a time, but when we paste them together, it makes it all into character.
Okay.
So right now we're still in this character format. So this is a good way. Say we have in an Excel, we talk about wanting to split everything out year, month, day. This is a great way. If you have a column for year, month, day, you would just put year, hyphen or comma, whatever you want to do, month and day. Paste them all into one column. And then we format that into a date, right? Or a date time. Okay, so that worked. So I'm going to just copy this and do the same thing for logger B. Change all the A's to B's. Okay. Do that, take a look. Logger B, great. That looks good. Okay. So I have the same column names, everything's sort of set up. Now we want to format those columns to make them into date time with Lubridate. So okay. So now back to your question. If we're using Lubridate, do we need to specify the sort of year, month? How does that work? When you're talking about earlier, what would if our format is this, what do we need to specify to convert it to date time?
Year, month, day, hours, minutes, seconds.
Year, month, day, hours, minutes, seconds. Let's take a look at the data again. Head of logger B. So what do you think will happen if we did year, month, day?
It would put it in like year 1.
Right. So year, I don't know what that would be. Year. If we're saying year is 1, year, month, day, we're saying the first year ever of January 15th, right? So this is the part where Lubridate is good, but it needs your sort of to look at the data and say like, and in this case, I know the data starts. This is 2015, right? But you might get data that you don't know, and this is why keeping your columns separate in year, month, and day is so helpful. Because if you get something that just imagine you got this, that could be a number of different things, right? Like you could go a number of ways, and so it's an important factor to think about when you're saving your own data or you're converting other people's data. Like you need to know. So in this case, this is actually month, day, year, and then hour, minute, seconds. I completely prefer to do year, month, day because I think makes way more sense and it sorts really nicely. But we're going to use this. So same thing. Let's use our mutate again. So I'm going to say logger A. Logger A, and I'll type that to mutate. And let's say I want to keep the same column name. I'm just going to use the same name and basically overwrite it, okay? And I'm going to use now this function, month, day, year, hours, minutes, seconds of the date time column. Any questions on this, what we're doing here? Let's run this.
So in your original time column, you don't have any seconds.
Right.
But
So,
it puts seconds when you create your date time.
right. So it will add, that's a great point. So this actually, let's add a comment. So it's glimpse. So notice it's added a seconds column here, right? So it's 0 across the board. So you can do the same thing if you just had an hour column and you want an hour minutes. You can just do HM. It will add a minutes, but it'll be 0 across the board for all of them. Yeah.
Why did you use if you're not actually adding another column?
Because you can overwrite the same column. So this is the exact same thing as.
You need to use mutate to do that?
Nope. I just wanted to show you a different way to do it. Let's do this. How would I do this now? Month, day, year, hours, minutes, logger, a, date, time.
Why wouldn't you have the seconds?
So I actually, let's just see what happens. Since we've already formatted it, actually, I'm going to rerun this chunk to sort of Okay, I'm not going to run this bit, and I'm going to run this way now. All formats not found.
It's because you already, in your date time there's seconds also.
There's seconds, right? So interestingly, it's recognizing this time as hours, minutes, seconds. So even though it only has hours and minutes here, when we pasted it together above time, so let's look at there we go. So do you see when we paste here, time only has hours and minutes, but when we pasted it together, it added seconds for some reason. That's okay. But that means that when it's looking at this format and it does hours, minutes, it's going to break because it's seeing something else here and it needs to know how to format that. So that's why we got that error message up here. Said all warning message, all formats failed to parse. No formats found because I have hours, minutes here and not hours, minutes, seconds. So great question and good catch. So let's change this to hours, minutes, seconds. There we go. Okay, well, oh, I have to redo it because it's now finding everything as NA. The great thing about code, you can always rerun it. Okay. Now, logger, a, date, time, month, day, year. There we go. That is much better. So let's look specifically at date, time. There we go. Notice that it has added universal time. So UTC is the default. If we wanted to add a time zone, so let's do that for logger B. We did logger A. And this was collected in California, so it should be like Pacific time. So let's do the same thing. Logger B, date, time, month, day, year, hours, minutes, seconds. Logger B, date, time. Now if I hit comma and tab, two options come up. Quiet, so one is it basically won't post those little messages. TZ, time zone. The string must be a time zone that works basically for your computer or for your that is in a format that it's recognizable. Does anybody know off the top of their heads how we find time zones in R? Trying to remember myself actually. Right, it's TZ, but if we want to know what the time zones are, so time, let's go to the Google. Find time zones in R. R time zones. That looks like a promising option. System time zone, location true. If I scroll down, names UTC and Cinnamon were accepted on all platforms. Oh, here we go. This is what I was looking for. So here, this buried down here. I could probably type sys time zones and it might spit it out, but this is what I was looking for. Right here, it sort of tells me these are the different time zone regions. So my bet is I probably want America, Los Angeles, but I don't think that'll work as listed. So I need to keep scrolling. Let's try sys time zone. And then if that doesn't work, we'll just go with whatever. America, Los Angeles. Great. So that basically is telling me my system is on American Los Angeles time. Let's try to paste this in here. Quoted. Okay. Now, if we do the same thing where we say head logger B date time, EST. Sweet. Works. All right. Any questions? So we now have read in 2 dates, times, and we've basically formatted them into date time. No? Awesome. All right. A few more things here, and we're going to switch gears. So I just want to show a few other LubriDate functions. Make another chunk. Other LubriDate. The one thing that is kind of nice, now that this is in a date-time format, LubriDate becomes really, really handy, okay? So one of the things that we can do is we can use, there's a whole bunch of functions, and if we're not sure what the functions are, I can do LubriDate, : and it brings up all the functions that exist inside LubriDate. Notice we can convert to decimal dates. We can do days in the month, decimal days, decimal hours, etc. Okay? So view functions. What I want to point out is a couple of them called, one is floor date or ceiling date or date time. This is handy for a number of reasons, but say you have, like we have this date, minutes, seconds, or whatever, and you only want to the nearest hour. So floor date, and I'm going to say logger B date time, comma, unit. And notice I can now specify exactly what I want: second, minute, hour, day, week, month by month. So if we want to round to the nearest, let's say to the nearest month. Oops. So unit is month. And if I'm going to actually pipe this to head. So notice now it's rounded all these to the same month. So it still retains the day, but it's rounded everything to the nearest month. Okay, floor of that month. So floor is rounding down, ceiling is rounding up. So let's see what ceiling does. Logger A, or B, sorry. Time, unit equals month. Head. There we go. Now notice, so let's, where does, let's see where it starts. So it's rounding from basically the 1st of January 2015, and the ceiling one actually rounded, it only took the first value, and then after that it rounds up. So anything after basically that 1st of the month, now going up, right? Whereas floor is going down. So depending on what you want. Does that make sense? You can play around with this as much. I see heads going like this. So it starts on January 1st, right? But as soon as it exceeds that sort of January 1st, 000, it's above January 1st, so it's going up to the next month. And that's why we're getting, the first value is January 1st, but after this, it's going up to the next month. Because our ceiling is actually by month, February 1st. Got it? It's totally irrelevant, but it can be handy at times.
Does it always add so if you say ceiling, it still adds the day under your date, right?
Right. So
that's just kind of like a dummy.
You kind of, yeah, but it's a way to like think about if you want to aggregate your data really quickly and just have a column that's, you know, rounding or floor, you know, that you can do that. If you want something to round, actually round to a given time frame, there's actually a round date. So this will similarly opt as the same thing. So logger b, date time, same thing, unit. And let's say for this, we want to, we want to go to the month. Well, let's do day, just because. And then pipe that to head. So there's that one. Let's look at what happens if I change this to month. The same thing. See, it's rounding across these things. You can play with these. It gets tricky. I honestly think the better way to do a lot of these is the functions that pull the individual pieces out. So year day is a good one. That will pull out the day of the year, month, a week, etc. Okay, so you can make new columns that have these data, and then you can group or do whatever you want based on those things, which I do frequently. All right, any other questions?
A lot of people are having the problem that they can't find the Los Angeles, the America/Los Angeles time zone.
Oh, right.
That's not working. That just was on there.
If you type in sys time zone, what do you get? So I didn't include that in here. Sorry, sys time zone. If you run that, what does your computer say? NA. So you don't actually have a system time set.
Okay, so that's why.
Which is interesting. So there might be actually a different name for your time zone.
Okay, yeah, on like the maps it's
Huh.
right? Yeah.
I can troubleshoot that later.
Yeah.
That's less
Important.
Yeah, less important. Okay, I'm gonna show one. So now we're gonna move to joins. And I'm just gonna, don't worry about the code as much as I wanna show you like how this works, and then Mike's gonna actually break down the pieces of it, okay? So I'm gonna show you a quick little sort of demo, and then we'll take a break, and then Mike will take over and do a better job keeping you awake. Joins with Lubridate. Okay. So we want to join these data sets knowing they overlap. How do we do this and retain only distinct data? So the answer is joins, and there's a whole bunch of joins options. But what I'm going to show you is essentially what's called an inner join, which means that it's taking two tables and basically only let's show a left join. Left join is joining one to the left side to the right side. But what it does is, so logger A, whoops, I'm joining logger A to logger B. Let's call this full logger. I don't know. And then by, this is kind of your grouping by column. And in this case, we have the same column name, so I can type in date time. So now let's really quickly look again at our data sets. So 17,000 plus, 20,000 plus, but they overlap by a month. Now I have one that is full logger is only 17,236. So I wonder what happened there. Well, that's because it's probably only joining the left that matches with the second. So let's not use that one. Did yours freak out?
It says 11 variables.
There we go. That's what I was trying to do. 11 variables?
Yeah.
Yeah, I'll show you why that in a second. Exactly. So actually, take out date time. Sorry. Inner join. What am I looking for? Full join? There we go. Thank you. So I took out the by here, and I'm going to show you why. Notice it kept 6 variables, and it's going to look exactly the same. So now, basically, we have a full join. If I say n rows of logger A plus n rows of logger E, what do I get? Oh, I get nothing. Get nothing. 38,014. So what it has done is literally just appended, a full join has appended both of these, right? Okay, that's cool, but that's not really what I wanted to do. I want to find where the things overlapped, right? So in that case, so this is basically appends all data together. What happens if I do full logger, or let's do full join by date time. Now, interestingly, what happens? We lost about 3,000 observations, which happens to actually be a month's worth of 15-minute data. So it has actually recognized that based on that date time column, hey, these are the same, I don't need to have the same data. So now we have a nice set of data. The only problem is we have 11 variables. So what's that about? Let's take a look. So if we glimpse full logger 2, look what it did. So it will automatically, anytime you have columns that are the same in both, it will add and append an X for the one that's on the left side and a Y for the ones on the right side. In our case, we don't really need all of these, and because there are some of these are sort of missing from one versus the other, it's put NAs. So it'll fill NAs for the one side versus the other. Mike will talk more about this, it'll make more sense. But essentially what I would next do is rename. So if we want to clean this data set up, now let's clean and rename. So first off, I'm going to select, so clean logger, full logger, shorter names. And now let's select, and I want the date time. And really all I want are the level. So I'm going to say starts with, so something we haven't shown you, which is kind of fun, starts with level. Or temperature. I don't think I need to quote this. We'll find out. What that is doing is it's looking across all the column names, and anything that starts with temperature, it's going to keep that column. So this way it'll keep both X and Y, because there's data in both that I want. And see what happens. Oh, it needs to be quoted. Okay. Maybe I have to do one at a time. Let's just try level. Okay, that works. Okay. Just as another fun thing you can do. So now we have in clean logger data 3 variables: date time, level X, level Y. And if we want to rename one of those to just be level, I can pipe this to rename and name it what I want to call it, lowercase level equals level.x. That's the one I want to keep. Okay, I'm going to leave it at that. So you can start thinking about ways to do this. We'll talk more about like how you might join so you don't end up with those .x's and .y's. But just know that these joins can get really powerful really quickly because you can actually start looking for, there's a similar thing called an anti-join, which will actually find any records that the records that don't match between the two. So if you have 2 tables and you know they overlap, and you want to find the records that actually don't match between either, you can use that, which is also really handy. Left joins, right joins, inner joins, we'll hit those next. I'm gonna leave it there, take a break, stretch, get some oxygen in your brains, and then Mike's gonna take over. The level has to be capitalized. This is the one that's renaming, and that's the one that has to match some other thing.
You know, back in
When you run system,
I think that's was
So
it's my responsibility I think they do have an internal review process, but I'm not sure.
that would be a question. GMT.
Yeah.
So you're in
I sort of did what
Greenwich
I needed to do.
whatever time,
They felt like they cracked that.
which is interesting.
But then, like,
That is, but that's fine.
Close it out.
Yeah. Look at and open daytime preferences.
It was kind of like, it's like imagine that you go to
So that's
station
just
and
where
you're like,
you are.
"Oh,
So that's where I would probably Google like setting times of communication
yeah,
because it's a system.
that would be nice. I can actually, I'll look and see what I heard last week.
But what you can do is you can actually tell it what times to use. But I think
How are you
it
doing?
uses America.
Are you getting ready for field work?
It doesn't use the Slack. I'll look it up because I know that's
When will you start?
From like 2 weeks to
Oh, yeah.
a little work getting out 10 days later. Oh, yeah, like, so you can set it at GST.
Right. Let's see. Yeah,
Yeah. Also, this person is on the map, in our session.
If you do up again,
that is the last thing I heard. And she said she would send it back, send a final version. Thanks for the email. I will, I'll follow up. And I'll email her, Mark, final version.
Did it work?
Send it.
sure.
Great. Yeah, I mean, for everything we did is done, like, we're complete. We just fulfilled the
Did you
audit.
say TSP? Yes, this stuff.
Oh,
Yes.
so
Right. Yeah, no, I mean, I was ready to send it to you guys, but I'm sending it to you.
Now it's a Los Angeles thing.
Yeah, I had the same problem. I couldn't figure out.
Like that's,
Yeah, no, I agree with you. It sort of has dragged
Yeah, but the part was always trying.
You know, what happens a lot in colleges is not geography. So this is like adding to our current
I mean, new columns on monkey, but if there's only
Another minute or so.
These materials are
that's okay. It's
And that was.
it's getting you weird. I don't know why. That's to do with your system time.
And have like the cell is just around memory.
Yeah, there's ways to sort of aggregate data based on, but it'll still keep the full timestamp, the full date stamp, but it'll round everything up or down. Those are also to create new columns to basically pull out the year, day, and the month. There's a whole bunch of add new columns to your data set based on those things. which I-
Okay, let's come back up front. All right, so let's get our hands dirty with some joins. And I would say that this is maybe like the final skill that we're going to be adding to your data manipulation toolkit, right? We've talked about importing and exporting data. We've talked about basic visualizations of data. We've talked about summarizing data, doing mutations to data to alter the whole data set. We've talked about reshaping data, changing it from wide form to long form. And so now I'd say merging data together is a really important skill. And so let's do some of it. So here on the website, the material I'm going to be working from is this joining data underneath course materials right here. And, you know, again, all of this material will stay up here and live up here. So you can go do a deep dive on joins later if you'd like. We're going to focus on a small subset of this. But this whole first part is really cool and sort of simulates some data. And then shows you all the different kinds of joins that we're going to do. We're going to focus on one kind of join today. And so what I'm going to do up here also, this button will show all of the code throughout the, show all the code throughout the document. So now these should all be popping up, right? So we're going to head down to here, practice with joins using the survey data. And let's start by going back to that survey data that we've used from the portals mammal data set. And so let's read in plots and surveys. And both of those links can be found on the Google Doc right here. So let's grab the link for plots. I'm going to try not to cut it in half like I did last time. Practice with width. I'm going to create a new trunk. And I'm going to say, let's see, the first data set was plots. So I'm going to call it, plots. Assign a new variable with the assignment operator plots read underscore CSV, and then in quotes, that link. Slow. And I'm going to grab both of these because we're going to need them eventually anyway. All right, close my parenthesis. Okay, so surveys is assign it as read underscore CSV, and then in quotes, this surveys data frame. And you can go grab all this code too if you'd like it saved from the live code if that's easier. Species read underscore CSV. Like that. Okay. And so let's read plots. And let's read surveys. And first thing that I'm going to do, right now I'm going to comment out the species. We'll use that later. First thing that I want to do is look at the data after I've read it in. So I will use a glimpse plots, and glimpse of surveys. So the plots data frame has two different columns, right? Two variables, the plot ID and then the plot type. And looking at surveys, we've seen the surveys data set before. This is the one with all 35,000 different observations with different records and different months, days, and years, different plot IDs, and then the different species that were caught in those particular traps, their sex, their weight, their hind foot length. And if I go to, so something to notice here is that between these two data frames, there's a common column, right? Plot ID is common to both of these data frames. Even though they're different sized data frames, this one, plots, is only 24 rows with 2 columns, and surveys is gigantic, right? They have this common column plot ID. And to visualize what that looks like and what we're going to do with it, I'm going to go back to our website. And here's sort of the crux of the problem, right? We want to take these two separate data frames, table X, the plot data, table Y, the observations, and we want to merge them together by this common column of, in our case, plot ID, right? So you can imagine a scenario where you've got the ID 1, 2, 3 on the left table and ID 2, 3, 4 on the right, and they've got different kinds of data associated with them, and then we want to merge them together such that, for instance, as Ryan mentioned, using a left join, retaining everything on the left-hand side and joining it with just the matches on the right, we end up with 1, 2, 3, north, south, east, all from the left side, and then the weights that match with ID 2 and ID 3, and then just a missingness, right, NA, where it doesn't match. So that's kind of the intuition behind what we're going to do. So let's see how that goes. And the syntax is join. Actually, let's use our pipe syntax. So let's take the surveys observations, and we're going to pipe it to a left join with the plots. And just like that, dplyr automatically goes and finds that common column, that plot underscore ID, and it grabs all of the plot ID information from the plots data frame and appends it to our surveys data frame. So this is hard to see because we've tell you what, let's select a few of these columns so we can look at them. Record ID, let's grab the plot ID because that was the common column. We'll grab the specs, and then we'll grab the, what's it called? Plot type, I believe. Plot type. So now plot type was part of the plots data frame, and all of the record ID and sex, that was all part of the surveys data frame, right? But we've merged them together into a single unit. Okay, so let's get some practice doing this. If I just leave the challenge right here, can everybody see that in the back? Okay, so start with this line of code here, reading in the species data frame. And in fact, I think that's the one that we commented out before. So read in the species data frame, and then write some code that returns the number of rodents observed in each plot in each year. And pay special attention here to the hints, right? So all the information you need isn't contained in a single table. The taxa information is in the species data frame, but then all of the observation data is still in the surveys data frame. So start by writing some code that joins those two together using that left join function. And yeah, green sticky notes up when you have that done, and red sticky notes up if you need a hand. Let me go make sure that I've saved this so that you can grab. Right, so this is the line of code here, this species from the website. That's not saved. Okay, and work with your neighbor. See if you can figure this out. So start by reading in the species data frame, and then join it together with the surveys data frame. So we're joining species and surveys using that left join function. Green sticky notes up when you're finished, red sticky notes up if you need a hand. Oh, you're good. I was only going to go for digress. That's fine. Awesome. Oh, cool. Okay. Oh, is it Karen? Yeah.
Oh, no, what are you? Oh, okay. That's how we talk about the
Where you going?
Here.
Oh, really?
Yeah.
Yeah.
And then in species, it has taxes, so it has them split where they are on it, and then you can see how they have taxes.
That's a good idea. Or do you want tax or do you want species?
Well, the species idea would give you the different species, but not the different. You don't care that it's like you have a mouse and a rat.
I thought that would be
I think the only I was like the species side.
total number of references
For each, not necessarily per plot, just for,
it says right because it returns the number of references in each block.
then yes.
Okay.
Yeah, let me adjust my
Non sort of like at that point and trying to figure out the same values. So add other things.
yeah. My apologies.
I just selected taxes.
Yeah, and then just like or any
So,
and then what I wanna know is
Yeah,
the
I mean,
surveys,
that has to do with
surveys,
parsing.
and then
If you have
a short line.
Yeah.
There's only one check.
So I was thinking you don't need to do big species, okay, choice, okay, where you do surveys and species.
Okay.
Right.
You may want to switch around which one you might be on, right? So left hand is it's going to retain everything collectively. So that's where the data are, that's where the observations are.
So what species?
Oh, sorry.
I had said surveys and species.
Surveys and species.
Yeah.
Okay. By species ID.
Yeah.
Right, so then you end up having species ID, and you get everything.
Sometimes it actually provides them more
And then, so, in theory, you have all the, so we switch together the plot item, or the species ID, insert all the other columns from both data. And then, wouldn't you want to group by plot ID in year, or year and plot ID?
Sure, yeah.
So that then you could do it. I do a tally, it would tally the number of, or it would be sum, not the tally, right? Not the number of cells, it's the number of, total sum of individuals.
What each observation could only be one of the, so I thought tally was right, yeah.
But, so then, does the tally, you type from the group by?
Yeah.
To the tally?
Yeah.
Does it tally within the group by?
Yes, tally is just a shorthand for summarize n equals the n function.
Okay.
Right, so you can always think of, I think, you can always think of group by and summarize going together. That's why I often write it always group by summarize. And then G instead of tally, because I find it.
So it's group by, and then I have plot ID, right? Okay, those are the two things that we want. We want by plot ID.
Yeah, there's one missing piece of information there, but I can send this to you if you have further. If you want to do it.
Okay. I'll go back. I'm just like, yeah, no, that's and then you type that to where you just need to condense everything into some combination of.
Yeah, or
Which would be tally or something. And that spit out what you do. Okay.
you simply run that tally.
Yeah.
What
Right.
then you can join.
Yeah, that will work, but it won't be exactly. Let's take one more minute and then we'll go through it.
So when you assign it, like nothing, you will get something back from that program. You need a sort of internal tax that you can write out.
What's up? What'd you find?
No, you just need to tell it what it's gonna tally.
It should.
You have to sort out that it's broken.
Exactly right.
You should do that before you do the group by.
That'd be one way to do it. Yeah.
You should select not or anything where taxes.
Select
Or, yeah, sorry.
the other one.
Yeah.
Yeah. No, exactly.
But use your default.
And so that's one way to do it. The other way is that you could either group by, also group by tax, and then drop the other ones after that too.
Okay.
So two ways to do it.
Yeah.
But yeah, that was the missing piece.
Right.
It's basically like I'm reading like this, so count everything else of the types.
All right, are we ready to see?
Yeah, because it's because of it goes okay.
I don't see that many green sticky notes, so we'll give you another minute. Green sticky notes up when you're finished.
So then after the tally, then you just if you do the where you use tax in your fruit box, then at the very end you just say we want to conserve things for tax.
Yeah, totally. Alternatively, if you're spinning your wheels, put the green sticky note up and we'll just do it. Like, be kind to yourselves. All right. I'm seeing a lot more green sticky notes. Let's go through this. Here we go. No, that's really important, right? Like, write a lot of code, but be kind to yourselves. Know when you're spinning your wheels and just go get the help. That's what we're here for. Okay, so if I read in the species data frame, I remind myself of what's in the surveys data frame. These are the different columns that are available to me. And these are the different columns available to me in the species data frame. Now I've got this species ID, genus, species, and taxa. So some additional information related to what these two-letter species IDs are, right? So the common column between these two data frames, between surveys and species, is the species ID, right? And part of the question asks us to filter down by taxa, right? So we're just going to be looking at the counts of rodents per plot per year, but taxa isn't available here in surveys. It's only available here in species, right? So let's bring this information up into our surveys data frames. And, I'm just going to do this piece by piece here. First, the join. So with the left join, we're keeping everything in the left table and just bringing in the matches from the right table. So we want to keep all of the observations, right? All 35,000, because ultimately that's what we're going to be counting is the number of observations. So I'm going to take the surveys data frame. I'm going to pipe it to a left join of the species data frame. And in our case, there's only a single common column between them. So I'm going to let dplyr figure out where that matching column is. Yeah?
Does it matter which you join to which? Like if you did species to surveys, would that give you a different answer?
It would, I think, because with the left join, we're just keeping the table on the left. So ultimately, we'd end up with a 54-row table with the information from the table on the right. And let's call this something. Join to surveys is assigned to be surveys with the left join to species. And so let's take a look at join surveys. So now I've got this taxa information for each of these 35,000 rows, right? So if there's multiple observations with the same species ID, the left join is just going to take all of those taxa and copy them over, right? So you're going to have more than one row with that taxa information if that species ID matches multiple times. Okay, so that's the join. There's a couple of different ways to do this next part. We want code that returns the number of rodents observed in each plot in each year. So if I'm thinking just the rodents, how do we modify our data frame so that we're just dealing with the rodents? What dplyr verb do I use? Filter, right. Filter with the taxa equal to plural, right? Rodents? Singular, all right. Now, I didn't save this to anything, but it did print it out. So this should now be a data frame just with the rodents. And you can confirm that on your screen, which is larger, that these should only have taxa being rodents. Oops. Great. Okay, so now I want to use this split, apply, combine strategy to get the number of individuals, number of observations per plot type per year, right? So if I'm thinking per plot type and per year, what's going to go in my group by? Plot, oops, group by, oops. Is there a plot ID, right? Oops. Plot ID and year. That's going to be splitting this whole data frame into these different sort of tinier data frames by each plot ID year combination. And then the summary that I want to do is I'm going to create this new column called N, where I'm counting the number of observations in each of those split data frames, right? So I'm going to use the N function. Alternatively, this is the same. I'm going to copy this here. Tally does the same thing as summarize N equals, and then the N function, right? So tally is a shorthand for counting all of the observations in those different subsetted groups. So let's see what this looks like. Okay, so now I have N, the total number of, we know that we've already filtered down to rodents, in each plot and in each year. So each row here represents a different plot ID year combination, and then N represents the summary of the number of observations in each of those combination types. Okay, so that's it. Yeah.
So the plot type, if we wanted to add the plot type, like the thing that says what type of plot it is, can we, at the point that we do our first join,
Yep.
can we do another pipe and then left join plot? Or whatever we call that other one?
Right, tell you what.
Plots is the one that actually has like the description.
Right, no, good thought. So let's try it, right? So write some code that returns the total number of rodents in each genus caught in the different plot types, right? And so this hint here is suggesting that, okay, now we don't have all of the information that we need because the taxa is in the species and the observations are in the surveys data frame and the plot type is in the plots data frame. So you all tell me, right? Take the next 5 minutes, use what we just learned, and see if you can join together 3 different data frames to get to this challenge. Get the answer to this question. So write some code that returns the total number of rodents in each genus, per plot type. Take another 5 minutes, work with your partner. Green sticky notes, well, all green sticky notes down to start. Green sticky notes up if you got it, or if you give up. Red sticky notes up if you need a hand. We'll be around. Yes.
And you want plot type.
Plot type instead of plot ID, exactly. Okay, live code is updated.
That's what I would think.
Okay, that's what I need some.
As long as it's on the left side. Yeah. Okay,
You do it the other way.
Okay, so that turns it left. I didn't. That's. Yeah, all right, well, I think.
I like what I'm hearing over here. Does this work? I don't know. Let's try it and see. That's a great strategy.
Efficient smoke starts
It
coming
works
out of
if
the
you don't.
chimney.
So we have one. Did it work?
Joining. Species before class. Yeah. I don't know. I got a weird message.
Okay, I didn't get a weird message.
Okay, let me see. Okay, is this the 60 dishes? So here's. Mine looks just like.
Oh, no. Okay. Wait, look at the, you got 13 variables.
Yeah.
Cool.
Okay, yeah.
Sweet. Look at this design. So you just did left and right. Okay. So I think I'll.
Is that what you're doing?
Something like.
Well, no, okay, so we have this, but it's in lines.
I don't know, we put the line.
Write some code returns the total number of
The
words.
machine is caught different plots.
Okay, so then we just select.
Yeah, Python.
Okay, so now we're just selecting.
I want years. I want years. So we want taxes.
Oh.
Oh no, but we want each gen. Okay, so we want taxes. Years.
No, we don't need years.
Plot ID. Oh no. Yeah. That's why we need the plot.
And that's what there's nothing in growing between genus caught in the different. So that's why. So that's the other guy. But then once we select them.
And then we filter taxes.
Because that's in the species one. Well, I already have the here, which is gonna be the other one.
All right, take one more minute. I'm seeing some green stickies.
Oh.
As we was.
All right, let's get back up front. So here's how I would do this. And riffing on the strategy that I was hearing, let's say we'll call it genus counts. So I know that I'm going to be counting the total number of observations. So if I'm thinking left joins, I want to keep all of those observations, right? So that's going to be my leftmost table, surveys. I'm going to pipe that to a left join of the plots data frame. Pipe that to a left join of the species data frame. And again, I'm going to let dplyr figure out what those common columns are, right? And there are ways where you can say specifically, oh, just join by this particular column. So you can look up some of the arguments to these joins on your own if you need that kind of flexibility. But dplyr is pretty good at figuring out what those common column names are all on its own. And just as before, let me get this up a little higher. We're only interested in the rodents. So we're going to use the information that's now joined into this bigger data frame, but it originally came from the species data frame, so we have access to it. Filter such that taxa is just singular rodents. And since we want the number of counts per plot type, per genus, and per taxa, and we're thinking about split, apply, combine, how should we be splitting this data frame? What should be going into our group by? Per taxa, per plot ID, per genus. Oh, sorry, not per taxa. Per plot type, per genus.
That's it.
That's it, right. The end. So those two, right, okay. Plot type. I think I did it a different way on the website. Genus. And then what is the summarizing function, right? So now we've successfully done the split part of split, apply, combine. What is the applied part? What are we applying to each of these sort of subgroups? Tally, sure. Okay.
So why doesn't it work if you do group by before you filter?
You do group by before you filter?
Yeah.
Because it doesn't conserve the taxa column.
Right.
But if you included, you could include taxa in group by.
You sure can. Exactly.
It would just
Group by
retain
taxa
it
equals
columns.
Right. And then you would have these different split groups would be by unique combinations of all three of those variables. And then you would want to filter after that. So let's see what that looks like. And presumably, for each plot type, now with the additional information, not just the plot ID, in genus combination, we have the total number of individuals, and we've just filtered down to the rodent taxa. So the answer, Mary, to your question is yes, you can filter or join multiple tables, more than two. How are we feeling about joins? Good? Okay. Go to the website if you want more information about all the different kinds of joins you can do. But yeah, we're going to show you how to create a new project so that you can take. Oh, we're not.
We are. I just wanted to point out if
If
you had columns with two different names, which is common, right? Maybe it's the same data, but it's named differently. You can use that by, and you could say, let's say, animals is the same data in each, but you want to join animals by dogs, because maybe all the animals are dogs, right? So you would be able to do that. So your join would be over here with your two data sets. And so you can actually list as many columns out as you want, but it's really flexible in that the columns don't need to be the same names, right? To join on data. So that's a really, I think, a super important point. And we don't have time to like go into all the different pieces of that, but know that you can think about it this way. This is a really, really flexible and powerful way if you have, say, just a table where you're sampling sites. You go out in the field, you sample, and you just want a table that has your X, Y, locations of your sites, and maybe some metadata about that site. And then you have all your data for those sites, and you go over and over and over again to those places. I mean, that's basically kind of what we're looking at, right? Like multiple times you go through, and you want to join those. You can do things like this, right? So you can join these together really flexibly, and that way you can keep your data very clean and tidy, separate. because they're different kinds of data and different tables. And then when you're ready and you want to sync those together, that's where this becomes really great. Cool? All right. So we have about 15 minutes, and we're going to basically take the last 10 minutes or so here to, so based on everybody's vote, it looks like we're going to do some spatial mapping stuff next week, or last week, okay? I do want to point out that, like Mike was saying, there's just too much to cover, and people are interested in a lot of different stuff, and we would love to be able to cover more for you all. Having said that, let me zoom out a bit. If you look on the website under course materials, there's a whole bunch of other stuff on here we're not even getting to, okay? There's some other stuff on the CO2 data. There's using PER, which is a really great package for looping through things. And so material there. There's some stuff on loops, and I know folks were interested in looping. PER and looping are sort of like the same kind of thing, right? Just different ways to do it. And then mapping. So we have a lesson now that we'll be doing next week called Mapping in R. It has a fun little map icon in there, which I'm excited to actually work. And if you work with text, there's also some text mining stuff there as well. Plus a whole bunch of, if you Google pretty much anything you want, now you hopefully are at a point where if you were interested in something, you can look it up and find something. That's the great thing about R. It's really flexible. So having said that, I think next week the plan is going to be, we're going to try to make a few maps. I would love if any of you have any like XY or sample site information or stuff you would like to map, send it to me and we can do a little demo and we can play around. I'd love to play with your data. I have some data that we can use, but it's always fun when we can like look at our own stuff. So whoever sends me something, that's great. I can use pretty much anything you'd like. So if you have a shape file that's not ginormous, that would be great. And if you have some point data, we can use that too.
What coordinate or projection?
Doesn't matter. Whatever you have, I'll show you how to transform it, convert it to different things. That's actually what's really cool about it. Okay, so that's the plan for next week. And so your assignment is basically going to be, I would love everybody to, we're going to work through setting up a new project and GitHub repository for this for next week. We're going to do that all together now. And then I would love for everybody, I will send an email or an assignment with the packages that I'd like everybody to have installed before next week. Because some of these spatial packages can be a little tricky in different operating systems, if you run into snafus, I'd like us to try to troubleshoot that during the week. And then we can all hopefully get to a point where we can start right away on next week. Okay, so let's go to RStudio. And, well, actually first, if we want to make a new project, I would like everybody to go to your GitHub page. Here's a quick trick if you didn't know. You can actually go, this is a GitHub repository, and if I just want to save myself flipping screens, I'm going to actually go to view this file on GitHub, which doesn't exist yet. Perfect. Best laid plans. Let's find one that is, I think this one is maybe. Yes, it is. Okay, something works. So that's actually, if you have a GitHub repository, you can flip really quickly to whatever that file is via RStudio. Okay, having said that, what I'm going to now do is go to my own GitHub homepage. So I'm signed in, this is me. I'm gonna go to my profile just to sort of see there's more frogs, surprise, surprise. There's a lot of stuff because I've been updating this website like twice a week. So this is your GitHub, right? You've been to GitHub. You probably have some idea of what it looks like. We're going to make a new repository all together. The plus sign is the quickest way to do it. New repository. And let's call it, you can call it whatever you want. I'm going to call it spatial. I do want to say that GitHub is great and that it will give you these suggestions for repository names. Like this, mine says stunning octodoodle. But they're all these like just randomly generated names. So if you want to have fun, you could like refresh your page and it'll keep changing, which is kind of fun. It's great, except then you have no idea what your repository really is when you're trying to search for stuff, and you're like, I mean, it's basically like my 2-year-old saying words repeatedly. Spatial mapping. So I'm going to call it spatial mapping demo, actually. And then if you want, you can add a description. It's up to you. I'm going to say some tools for mapping in R. Okay. Here's the part that I want everybody to play around with. So I'm going to make this public so you can all see it and everybody can see it. If you want, you can make unlimited private repositories. That's the cool thing if you all signed up with your student account, right? What's awesome about that, you can make as many as you want. There's no limitation, and I'm pretty sure that continues for as long as you use GitHub. So there's no reason to not do a private one. But I also would say the odds of, unless you have some very, very sensitive data that you absolutely can't put out publicly, the odds of somebody going to your code and like doing something with it and finding like is really slim. And so kind of getting in the habit of making public repositories can be a good thing. Just having your stuff out there, because it actually also gives your it's a way to sort of show on your CV like, hey, I have these repositories where I'm actively making my code available and stuff like that. So for now, I'm gonna make this public. I'll let you decide which you would like. Here's the other part. I'm going to go ahead and initialize this with a README. This is actually somewhat of an important point if you're trying to do this process. If there's a file in here, README file, it makes it much easier to pull it into RStudio because there's something that it can pull. If not, you can have some weird snafus. So I'm saying yes, and then I'm creating a repository. And that's it. I'm not doing either of these at the moment.
Should we do this in our own?
Yep, you should do this from your own GitHub.
Okay.
So you do not have to be in the GGE thing right now. Certainly you can do it from there, but for now I want to show you how to do your own repo so you can do this, keep your own stuff. Okay, there you go. So I have a public repository called Spatial Mapping Demo. Okay, here's the fun part. So now I have this repository. If I want to add you all so you can see it, it's public so anybody can see it, but say it was private and I wanted to add you, I can go to Settings, Collaborators, and it will ask for my password. So that, and then it says this repository doesn't have any collaborators yet. Well, I can do ents. Does it show up? Oops. Nope. GGE. Doesn't work. How do I do that? If you want to add well, mine's public. I can let's say, for example, I want to add Mike to this. So what you can do is use an @ symbol or just type a name. What's your
Mike. Oh, sorry, M-I-K-O-O. Yeah, it's 4 minutes.
There we go, Michael Kuntz. So if I highlight his name and hit enter and then add collaborator, there we go. So now he will basically get an email saying, hey, do you want to be a collaborator on this repository? So this is a cool way. If you have a private repository, you can share it with other people so they can see it. And that's basically what our ents group is, right? Like our GGE ents group is essentially a way to group share our repositories with each other, even though they're private. And I thought you could do it this way, but maybe it has to be private. I'm not really sure. Anyway, there you go. So we have a repository. Now we want to make it in RStudio. We want to pull it over. So let's go back to our main page. Spatial mapping. I'm going to click that button. I'm going to use SSH just because that's what I have. It works best for my computer. But you may want to use HTTPS. Whatever one has been working for you, go with that. Okay, I copied that link, and now I'm going to go back to RStudio. Okay, new project, right? New project. version control, Git. I'm going to paste that link and hit tab, and we'll automatically name the project the same, which is what I would like. I have mine as this in this subdirectory, but you can put yours wherever you're keeping your GitHub repos. And then I'm going to say create project. Now, wow, that was really fast. Hopefully, something like this happens and it opens a new project. So hands up if it worked. And if you would like help, put a sticky up if you don't have a spatial mapping demo. It's totally okay. Haley, did you get, is yours working now? Yes. Good. Okay. Sweet. All right. So now this is what we have for our next week, basically. Let's make a new script, just a regular R script real quick. And I want us to, I'm just going to write down some libraries. And I will send this assignment out to you all so you have these listed. But this is what libraries we're going to want. We want SF, maps, library RG all, library map tools, and library map view. I think we'll start there. So I will put this up on the assignment so you have them. I think there's a few other I'm probably may not be remembering. Those are the main ones. Oh, leaflet. That's the other one. Library leaflet. Okay. So what I would like you all to do, and you can install these all at once if you want. If you go to install packages and type these in, one separated by a comma or a space. So SF, RGDOL, etc. I wouldn't recommend doing it now because some of these take a while to install. Or if you want, you're more than welcome actually, because we'll be here for a little bit longer. But try to install these. If you run into issues, please let us know. We'll help you troubleshoot, okay? And then starting next week, we are going to, let me just give you a quick demo. Oh, here, I'll copy this to the live code, yes. Great suggestion. This is actually a good example. So I have this project open, but I closed the other one. So I want to open that other project and keep this one open. So I'm going to go over here to the projects button, go down to R Davis live code, and see this little button on the right. It says open project in a new session. So I'm going to click that instead of this. And what it does is it opens a separate that project and keeps my existing one open. There we go. And I'm going to go down to the bottom of this. We'll add a new section. New spatial project. Install these packages for week 10. Oh my goodness, we made it nearly. There we go. So that's what I would like you all to do for this week. It's pretty simple, hopefully. And thank you. And next week is our last week. We're going to do some spatial mapping stuff, but then we also want a chance to sort of talk to you all about where this class goes in the future. We're trying to make the case that it should be offered every year for students in GGE. And so it'd be great to get your input and talk about that a bit. And then there's also sort of, I don't know if you remember, at the beginning of this whole course, we did a survey, a pre-course survey. We would like you all to do the post-course survey, because that's the data that will help us sort of evaluate and make the case that this sort of thing is important. Mike and I and Michael and everybody who's helped with this class would advocate that yes, it is. But having data helps, right? So if you can, as always, jump over to the Google Doc and please fill out how today went. The survey should be at the top. In class, there we go. end of class survey. So if you can jump over that, fill that out, give us some feedback, and get those packages installed. And stay tuned, and we'll see you next week for last week. Thank you, everybody.